You'll be surprised how many springs really behave very nicely according to Hooke's law. I have one here. That's not a very expensive spring. You see it here. And there is here a holder onto it, so it's already a little bit under stress. That doesn't make any difference. These marks here are 13 centimeters apart. And every time that I put 1 kilogram on, you will see that it goes down by roughly 13 centimeters. It goes down to this mark. I put another kilogram on. It goes down to this mark. I put another kilogram on, and it goes back to this mark, all the way down. And if I take them all off, so what I've done is I effectively went along this curve, and if I take them off, if it is an ideal spring, then it goes back to its original length, and which it does. That's a requirement, of course, for an ideal spring if it behaves according to Hooke's law. Now, I can, of course, overdo things. I can take a spring like this one and stretch it to the point that it no longer behaves like Hooke's law. I can damage it. I can do permanent deformation. Look, that's easy. For sure, Hooke's law is no longer acting. Look how much longer this spring is than it was before. So there comes, of course, a limit how far you can go before you permanently deform the spring. What I have done now with that spring, probably in the beginning, I went up along this straight line, and then something like this must have happened. I got a huge extension. My force did not increase very much. And then when I relaxed, when I took my force off, the spring was longer at the end than it was at the beginning. So I have a net extension which will always be there. And that's not very nice, of course, to do that to a spring. So Hooke's law holds only within certain limitations. You have to obey a certain amount of discipline.